Good morning, everyone. It's a pleasure to be with you today as I will be joining you to talk about the digital enterprise vision and the technology trends that are happening in this environment and how they are shaping the future of the IT. First of all, I would like to thank the Telecommunication Regulatory Authority and the TRA Academy team for giving me this opportunity to talk about in front of you about the technology trends and our vision in this area. First of all, my name is Faris Hassani. I'm the CTO ambassador for Dell Technologies in the Middle East, Russia, Africa, and Turkey region. I've been with Dell Technologies for almost 7 years now as a digital and technology consultant across different countries in Middle East, Africa, North Africa, and Turkey. I have led multiple digital transformation projects, mainly focused around digital transformation, cloud computing, multi-cloud computing, where we helped a lot of organizations in UAE and the Middle East to transform their existing modern data center to a sort of infrastructure that is a modern infrastructure over there. From a personal perspective, I graduated as a telecommunication engineer from l'École supérieure d'ingénieurs de Beirut, the St. Joseph University, and I did some work in Switzerland at l'École d'ingénieurs d'architectes de Fribourg, and also I hold an MBA from Warwick Business School. I like traveling, reading, and hiking, and hopefully after this crisis, this COVID-19 crisis is gonna finish, we're gonna go back and enjoy our hobbies and enjoy our life. I trust that everyone agrees that we are currently living in the digital age, or using the words of Klaus Schwab, the head of the World Economic Forum, the fourth industrial revolution. Digital is becoming an integrated part of the life of every human being, of every organization. And we are seeing a huge proliferation of the digital transformation in every aspect of our business. Even if I want to refer, there is a book that is being written by Max Tegmark that talks about not even a revolution, a new sort of life. It says life 3.0, and what Max defines in his book as different types of life. So we have life 1.0, which talks about the evolution of hardware and software. This is when we talked about the evolution of microorganism or the biological stage, if we believe in the Darwinian way of looking at things. And then life 2.0 comes with the cultural revolution. This is where you evolve your hardware, but you design most of your software. And when we talk about software in the cultural stage over here, we're talking about the brain shaping that has helped humanity, in fact, evolve. And technology has always been a driver for this evolution. On a side note over here, there is a very interesting book that is written by Yuval Harari. It's called Sapiens, that addresses the evolution of humankind and talks a little bit about this concept of life 2.0. And the final part, or what we are currently living, what we call the human in the age of artificial intelligence, is life 3.0, where we hope that at a certain time we're gonna be capable to design both hardware and software. We're gonna see an extension of the capabilities of human beings in this field, adding the capabilities of the machines, the artificial intelligence, and unleashing the power of AI. And the most important part of this revolution will be matter turning intelligent. And when we talk about intelligence, if I may, we can define it by the ability to accomplish complex tasks. And funny enough, in fact, we're seeing the machines becoming more social driven as well. We have seen social interactions through speech recognition. Machines are becoming to talk, to feel, and to understand what we are saying. So they have come to this stage of learning, which used to be, in fact, one of the let's say main advantages of the human beings now that we are sharing them with machines, and maybe they will come and overtake or expand on the human intelligence. Today, there has never been a more exciting time to be in technology and in IT. We're gonna talk in this session about the main trends that are shaping the IT industry, how we are seeing the changes over there, what are the technology trends that can help to this achieve this evolution. So to start with, if we can look at the existing infrastructure or existing IT environment that we are used to, we have been used to building and centralizing data across our existing enterprise data center, the one that is here on the center. And lately, in the last decade, there was a hype, or there was a surge of what we call the public clouds and the software as a service. So public clouds, we can talk a little bit about stuff like Microsoft Azure, Amazon AWS, and Google Cloud Platform, Oracle, and there are plenty of other players as well that are coming into this action. Software as a service, I believe that everyone currently is sort of familiar with Office 365, with Salesforce for organizations that are sharing, for organizations that are using CRM on the software basis. So software as a service as well has become a sort of a standard in this perspective. We have our main data center servicing our mobile users, branch offices, and factories and hospitals. So the first change that we are seeing nowadays is that there is a expansion of topology, if I may say, and the three main components, or the three main pillars of this change, would be the 5G network, the cloud data collocation, and the proliferation of edges. So if we start by the 5G network and the concept of 5G, beyond the idea of adding huge bandwidth and reducing the latency, so we can start having communication in a better way, enhancing the performance, because historically the cellular network has been always seen as a sort of a bottleneck in terms of bandwidth and latency. With the 5G network coming into the picture, and with the different features like enhanced machine-to-machine communication, ultra-low latency, and all the capability that it's driving, we're going to see the 5G network as an extension of our enterprise data center network in this perspective. And on top of this, we will be capable of using the 5G capabilities not only as a pipe to transfer data, but also to run our applications over there, which is one of the huge advantages that 5G bring into the picture. Also with the capabilities of network slicing, where I can put a certain quality of service for my application as well over there. So 5G by itself is a huge evolution, when it comes to the telecommunication world, and we are gonna see an increased usage of it. Also, I can see that this is the first step towards what we call the augmented reality and the artificial reality, and 5G by itself will help us move into this direction. The second trend that we are seeing is cloud data collocation. So we are all familiar with the concept of private cloud, public cloud, hybrid cloud, and nowadays we're talking about multi-clouds. This has become the standard of how organizations are operating. There is no one single model that is prevailing. In a way or another, every organization is using its public cloud, its own capabilities, and extending some functionalities to the public cloud, and using software as a service. There has been a huge debate as well, which one is better from economics perspective. Everyone has his own opinion over there, but at the end of the day, it all depends on on the use cases. However, what we are seeing nowadays as well is an emergence of this concept of cloud data collocation, which is a very simple idea that I can put my data on a certain repository, and this data is going to be accessed by different applications. Either they run on public cloud, either they run on my private cloud, on software as a service, etc. So this will give me the flexibility to move my applications wherever I want, not being stuck to a certain public cloud vendor or a software vendor, and be flexible in my operations. So this is the way that we are seeing it. Added to the fact that the third concept, which is the proliferation of edges. And over here, we're in the next 5 to 10 years, I believe that edge with the concept of IoT is gonna be the main driver for IT. Traditionally, we were talking about not putting a sort of an email server in my factory or in my hospital, because I don't want to disturb people over there with IT operations. However, what we are seeing now, in fact, with the amount of data and the sources of information that are being generated from those edges, which are hospitals, factories, research and development centers, is huge. And the edge concept came into action because I want my computing and my memory and my application to be as close as possible to the source of information, because I want to run what we call real-time analytics environment. So that's why, in fact, edge has become so trendy, if we can say it that way. And we are seeing the edge concept coming into different sectors as well. So first of all, since we are in this unfortunate crisis of COVID-19, nowadays smart care, telemedicine is becoming a huge topic. And this concept is getting to a point where I need to use my edges. I need to use my edges so they can communicate data. So for example, of healthcare, in fact, the wearables, the applications, those can be defined in a certain way as edge. And in order to put, for example, a sort of teleambulance with a sort of a server that is inside that would allow the doctors to provide a quick care for their customers, I need a sort of a device that is being put into the ambulance and that will be capable to process the data and take decisions in a fast way. In factories, they are generating huge data in terms of what edges can help with. We're using the real-time analytics is, for example, the maintenance, how to optimize the productivity, and all those concepts. Another very important use case for the edge can be in the transportation field, where we have smart transport, intelligent connected vehicles. And by the way, there is a huge investment that is being put into the idea of autonomous vehicles. I'm sure that everyone is following Tesla and Mr. Elon Musk on what he's doing over there, and plenty of other companies. So we are seeing, in fact, autonomous vehicles coming in the coming 5 years, and those by themselves, they will generate huge amounts of data, and that's why they will use the concept, in fact, of edges, either inside the car or in the cellular network and in the enterprise data center. So just to summarize it a little bit in terms of edges, we can see at least 4 types of edges in the coming 1 or 2 years. And also there might be 10 more coming down the road, but at least the 4 that we're currently seeing. 2 are in the 5G network, 1 which is close to the mobile users. It could be at the cell itself. 1 that is also in the back end that will help aggregate the data. So these are the 2 types of edges that are in the 5G network. And the 3rd type is the one that we talked about, that is this type of edge, which is at the end of the day compute, memory, storage, that is gonna reside into my factory, my hospital, my R&D center, that's gonna process the data in real time and be capable of providing me the results that help me boost my productivity, enhance my business, and at the end of the day, gain some competitive advantage. The 4th type that we're seeing, and this is to tell you where that the edge is a serious story is coming from the public cloud provider. And over here, if I may take the examples of Amazon, they have released Amazon Outpost, which is a sort of an edge that is an extension to the public cloud. Microsoft Azure Hub or Azure Hub Stack, which is also an extension of Azure. And this comes from the concept or from the story that you need the processing power, the computation power, to be as close as possible to your environment, to the source of data. So if we can summarize this slide in a quick way, we're talking about 5G network, cloud data collocation, and the proliferation of edges. This is the way that we are seeing the topology expanding. The second trend that we are seeing in the market is related to the servers. All of us think of the server as a platform to deliver x86 power or computing power, Intel cores or AMD or whatever. However, what we are seeing over there as well is a change in the nature of the server itself, as it's becoming a platform to deliver multiple technologies. And when we talk about multiple technologies, I mainly talk about accelerators. Some people also, they talk about hyperconverged infrastructure, which is a server combining storage, compute, and software-defined storage, software-defined network. So everything is managed over there. So to be clear about it, we are changing the way that we look at our servers. Those servers as well are changing in their shape. We are let's say working on decreasing the footprint of the server, so it can be accommodated. For example, it can be put in a car, it can be put in a hospital, in an ambulance, at a house, so it can process the data in a very fast and effective way. So servers are changing, and those accelerators, we're working, and plenty of other companies are working on different types of project. One of the famous one is the Gen Z project, which would allow one server, in fact, with a certain type of compute and memory to be connected to multiple accelerators, depending on the use case. Either those accelerators are GPU, PCIe cards, or FPGAs, etc. So there is a lot of work that is being done over here in terms of accelerating the servers. So when we talk about accelerators, this is not a new concept. We have different types of accelerators being already in the market, and few more to come. So we have what we call the x86 quick assist library, which is an environment that helps, in fact, or it's an added library inside the chipset of the x86 that would allow you, in fact, to have faster mathematical computations. We have this sort of non-AI accelerators, and when I talk about non-AI accelerators, I mainly mean general processing, graphic processing unit, and FPGAs, which are a sort of a board that is being added next to your CPU, next to your cores, in order to boost the performance of those servers. Currently, what we are seeing is that plenty of people are using artificial intelligence and machine learning types of workloads, and what they are doing from the back end on the server side is that they are adding and increasing more GPUs. GPUs, by their architecture, they help increase the computing power because you have a lot of cores that are included in the GPU. And this could be a good case. However, GPUs and FPGAs weren't created to go and to address the artificial intelligence, let's say, type of workloads. GPUs are general. They can be used in VDI type of workloads. And now with the surge of remote workforce, we are seeing how much is it important to have this user experience, and that's why it's very critical if you want to deliver sort of videos and to be capable to enhance the user performance, to put those GPUs inside your environment. So they help in VDI, they help in plenty of universities that are running, for example, advanced math function softwares like MATLAB, like AutoCAD, etc. Also, they are using GPUs over there. So it's a multi-use environment, and it can be used for AI. However, just one point related to AI and artificial intelligence, and the main breakthrough that came into this technology or this field is related to the capability, as we said in the beginning, of learning. Machines now can learn, and the main, let's say, the main architecture or the main framework that is being used for learning in the artificial intelligence side is the neural network. The neural network has its analogy with our neurons in the brain, where neurons learn because they by changing their behaviors. In fact, through synapses, if we take the analogy of the brain. So now we are seeing our machines learning. There are different types. In fact, you will listen to different people. There are different types of categories of learning, of machine learning, deep learning, reinforced learning, and many other fields down there. There used to be a theorem in computer science that says NAND gates are universal. Nowadays, in fact, in artificial intelligence, we are seeing that neural networks are universal. They are being used left, right, and center in every AI and machine learning environment in order to enhance the learning experience of the machines. However, those types of frameworks or those types of processing algorithm, they need huge computation power, huge storage power, huge memory power as well. So that's why companies have started lately working on this concept of general AI type of accelerator and specific AI type of accelerator. So general AI, what I mean over here is that they aren't specific to a certain framework. They aren't specific to TensorFlow. They aren't specific to Caffe. They aren't specific to any type of framework that we are talking about over here. While specific AI, for example, is the type of processing unit that are specific, for example, for TensorFlow. And Google has released a TensorFlow processing unit that is optimized only for this framework. The main thing added to the power, for example, if we talk about a CPU being at the power, if they give me on a scale from 1 to a million, if they give me a scale of 1, non-AI GPUs are giving me 1,000. General AI and specific AI, they will be giving me 10,000 and 100,000s of performance that I need for my neural networks environments and my machine learning algorithm. Added to the fact that those accelerators will be measured based on measured on the power of the performance that they are giving. There is a very other important factor that needs to be considered as well, which is the electricity consumption. All of us who work in IT know how much, in fact, it is important to accommodate for extra power and extra electricity when it comes to using GPUs. Even sometimes I need to change the type of sockets in my data center. General AI and specific AI processing units will be also working on optimizing the watts usage, in fact, or the electricity usage for my environment or for my servers. So they will be judged on a performance per watt sort of measures, if I may say so. So those servers, as we talked, as they become more integrated inside our server, they are gonna be spread in our 5G network. They will be put into our mobile users, maybe using enhanced miniaturization processes, and also in different types of edges that we will be looking at. Now the fourth trend that we will be talking about over here is gonna be the network capacity. Network has always been one of the main components inside my environment. People usually used to use the network as pipes to transfer the data. First of all, we have seen, and maybe the people that have started with networking background, at the first we used to say that 1 meg and 100 meg and 1 GB is a big dream for us. Now we are seeing environments at 100 GBs, and we're talking about terabits of second in the future. So in terms of speed and in terms of enhancement to the advanced networking, we have seen huge advances over there. We're talking about, as I said, terabits of second coming in the coming years, in the near future. We have this extension with the 5G network that we're talking about, which would decrease latency to its minimum, and also we have those new data center fabrics with huge capabilities around them. There are plenty of projects in the network field, open source projects as well, like Gen Z, OpenCAPI, and CCIX, that are working in such type of environments to increase or to work on enhancing the network speed and the network and to decrease the latency. However, what I can see from capacity perspective, or from a huge change in network, is more related to the network becoming more of a virtual system, becoming software-driven network. And this trend has started a few years back with the likes of Ensira from VMware, and then we jumped to Cisco with the application-centric infrastructure sort of environment. Also, we are seeing this in the SD-WAN with the huge change on the way that we do our MPLS networking. So to go back to the idea of software-defined networking, traditionally, as I used to say, we used to look at networks as pipes that are circulating data. Without knowing, in fact, how am I going to implement QoS over there, how to prioritize my traffic, which application is gonna get more priority. Then we used to do it through VLANs and all the stuff and some enhanced quality of service capabilities, but still we were looking at them as pipes, and usually the network teams used to be a different team than the applications. When I wanted to change, for example, a certain policy in my firewall because my application required this, it used to take me hell of time in order to do it, because I need to talk to my network team, to my security team, to all the teams that are involved in the networking. And sometimes this change could take months because it's related to our security policies. So it was very difficult to touch this castle, or that we call networking. However, with the proliferation of applications and the speed at which we are provisioning applications, this concept needed to change. And that's why when people came into the picture, they started looking at the most important part of my business, which is the application. Every other let's say infrastructure or every other component of my environment is gonna serve my my application. That's why application has become the centric of the topology, at the center of the topology, and you have the storage, the network, the compute at its service, and we are seeing all of them and plenty, a huge portion of those elements becoming software driven. So to go back to the network story, with software-defined networking now, I can implement it by application. I can use features like micro-segmentation, like distributed firewalling, distributed logical routing. I can even put security policies related to on a VM per VM basis. I can do this concept of handling east-west traffic and north-south traffic using only software that is being run on servers. In the network, we used to put routers, firewalls, IPSs, IDSs, different types of network access control for those people as well that used to experiment this product. So we had different types of hardware that is being implemented. And what we used to do is add more and more hardware. This is the control plane from a network perspective. This network plane from a compute perspective is from network perspective, sorry, is changing and is becoming a sort of a function or a virtual machine running into my environment. This will help enhance the business capabilities. It will help me have faster response to my business whenever I have a sort of change to my environment over there, and it will help as I said, increase the business productivity and have faster returns when it comes to provisioning applications and putting my security policies over there and all the network policies related to it. The fifth trend is related to storage. Storage is a pillar when it comes to our new digital enterprise, because this is where our most important asset is running, and this is where I'm gonna perform my, let's say, my computing in a certain way. Also, there are some companies that have recently released types of storage that run storage and compute power at the same time. So storage is a very important concept. It is where our data is running, and plenty of people are talking about the data decade. Sorry, in fact, we are seeing that there is a huge increase in the amount of storage that people are generating, especially with the type of Internet of Things that is going to generate huge types of workloads. And if we take just one example, which is the autonomous vehicles and intelligent connected vehicles, those cars are going to become a source of a data and generate data. Like one car might be capable of generating data as much as an enterprise for 1 year. So a car driving, an autonomous vehicle driving on the road will be capable to generate data similar to what an enterprise used to do, in fact, for 1 year. So the amount of storage is going to keep exploding. We are going to see, in fact, more optimized and more performing storage coming into the picture, reduce the price of storage per terabyte. And this is the general trend that we are seeing, and it's good that we are seeing it either in compute, in storage, in networking. We are seeing for example, in compute, the price per processing is going down. The price per terabyte is going down for the storage. Also, the price for the network, for the software-defined network, and the bandwidth is also going down, which is also a huge economic driver for the business and for the let's say the advance of the economy. Going back to our storage story. At least people keep talking about, okay, now we have HCI, we don't need storage, we don't need traditional storage anymore. Now we have public cloud storage, we don't need traditional, or why do I need artificial intelligence and high performance storage? There will be no one answer that's going to address all my applications. The difference between people keep using the term electricity when talking about IT, and I see them as very different for one reason, that in electricity you have one single type of utility, which is the current the electrical current that you are going. In IT, it's different. In IT, you have different types of applications. You have different types of services that you are providing. So there will not be a single answer that can accommodate all those infrastructures. So for the time being, at least, we are going to see, in fact, at least 3 types of storage. We have the traditional storage, which I will keep running for my databases, my open systems, my existing systems, my mainframes. This type of storage is required because it provides, besides the capacity that's being built into it, it has the capability to provide me with services, with data backup, with reliability, availability, serviceability. So the intelligence, in fact, of preserving the data is not being built on the application itself, but it's being built on the storage box that will help me do this, and this will continue, in fact, for a long time to go, especially for different types of applications that don't have the intelligence to do it, which are 90% of the applications that we are currently using. There are some new applications, some new databases that have built-in sort of services like Cassandra, MongoDB, and others. But the usage of those, in fact, when compared to the overall enterprise architecture, is still at a very low level. So traditional storage is going to be there. It's going to keep growing for the foreseen future. On the other side, what we are seeing as well is our new technology that are coming into the picture that will help us accommodate for this storage explosion that we are seeing, in fact. And when I talk about enterprise application integrated storage, I can see 4 sub families under this, which are, for example, hyperconverged infrastructure. A hyperconverged infrastructure is simply, in fact, a sort of a servers plus storage, plus even sometimes network added to it with NSX and others. So it's a sort of a data center in a box that is being pushed to the customers. We have different flavors over there. You have the VMware flavor, the Nutanix, the HP, etc. And also you have the software defined storage that could be built without being put into an HCI. Here, for example, we can talk about the likes of Scale.io, of vSAN, if you want to run it not in an HCI mode. Also, we have what we call the public cloud environment, and this is where I have, for example, Amazon S3, Microsoft Azure file systems, and blobs. That I can leverage for my storage environment. And also I can use my arrays, which are the traditional storage that I have. The main difference over here is that the way that you manage it. So in traditional storage, you have a storage team, a sort of a separate team managing the storage as a storage, if we can say. And in the integrated application storage, the management is not from the storage level, it is going to the application level. So for example, if we take an example of VMware over here, I can manage vSAN from my vCenter, which I use for my application and compute. So the application is the one managing the storage. The same thing applies for public clouds. The same thing applies to the software-defined storage. So the main difference between traditional storage and enterprise application integrated storage is the management layer, if we can say so. So the traditional storage, the management is coming from the storage side. Enterprise application integrated storage, the management is coming from the cloud. The last type is the high-performance storage, and over here we're talking about platforms that can deliver tens of millions of IOPS. And when I talk to different people about this, and they tell me, like, why do I need millions of IOPS for my database? I can run it. It will need maybe 100,000 at the best case. Why are you giving me a storage for, or why companies are investing their money and their engineering in storage platforms that are capable of delivering millions of IOPS? It's true that my database is currently needing a minimum amount, but if I think about the future, and if I think about AI, ML mainly, in fact, and all the investments that I'm putting in terms of compute, especially when it comes to increasing the compute power with parallel computing, high-performance computing, adding accelerators, I don't want to have a bottleneck, which is my storage, because by its architecture, AI will require a huge access, a continuous access to my data. And if I go with the traditional storage, this will be a bottleneck in my environment, and I will not be capable to deliver in a very fast way, especially when it comes to training models, and most importantly as well, the inference that is coming after I train my models. So those type of applications, AI, machine learning, advanced analytics, will require huge amount of IOPS, and I don't think even that with the current state we will be capable to respond to it. But as you always know, in fact, technology will keep evolving, and we will see more advances in this area. So for the time being, we have the traditional storage, we have the enterprise application integrated storage, and we have at the end the high performance storage. Depending on the use case, we will choose which platform is right to be put over there. The last, if we also can talk here about where I'm gonna see those types of storage. So that the only place where you're gonna see those three types of storage, the integrated, the traditional, and the AI ML type of storage, is in your enterprise data center. And the cloud and cloud data location and software as a service, we're most likely gonna see the enterprise application storage. And edges, depending on the type, we're going to use the AI ML because there is a lot of real-time processing over there added to the enterprise integrated storage, especially sort of HCI-based environments. This is the last trend that we're going to discuss today. There will be other coming in the next session next week, but over here I want to focus about the application delivery environment that is coming to the picture. So to start with, we have different types of applications, and what we are currently noticing is that the way that we are delivering those applications is changing. So even from a coding perspective, in the early stages, we used to, or developers used to write the code with the intention of where to run it. They used to know that I'm going to run it on a Windows operating system or an Ubuntu OS or a Linux, Fedora, etc. And they used to write the code based on this environment and used to build the connectors to the databases, etc. Nowadays, developers are writing the code without having the intention on where to run it. They are writing the code so they can run it on cloud. They can run it on their private data center. They can run it anywhere they want. And this change as well is affecting the way that we are delivering our applications. Also, from discussions with different teams, we see that plenty of people think that, okay, we have moved from bare metal to virtual machines, and now with the containers coming into the picture, we're going to move my virtual machines to containers, and then I'm going to move my container to PaaS, and then function as a service at the end. Well, it's not an evolution process over here. In fact, virtualization, for example, has been here, at least from VMware perspective, since 1998. And plenty of our environments are still running bare metal. So it's not any, as I said, it's not going from one phase to another. It depends on the application. And that's why when I talk to people, I talk about a very important concept, which is the application factory. So depending on the type of the application that you will be having, then you can decide where to put it. So for example, if I have a sort of an AI machine learning application that requires to have access on to the hardware directly because it needs the performance of the hardware, I will run it on a bare metal environment. If I have an application that is, that has the capabilities that is sort of stable, that wants high availability, where I know the performance is going to be steady, I'll put it on a virtual machine because those environments are steady, reliable, etc. And then I have the third type of applications that keep changing, that I use for sort of my development environment. Those I can put them in containers because they are flexible, they continue changing, and I need this flexibility of deployment, quickly deploy them at any time, at any on any environment. So for those type of applications, I'll use containers. If I add more intelligence on top of this and services, I can go to platform as a service, and function as a service will be very important when it comes to streaming applications where data are moving like a sort of pipe. I can use sort of function as a service or serverless environments. And where I can see those environments depends on multiple factors. In my main data center, I'm gonna see, as you can see over here, all the 5 topologies: bare metal, virtual machines, containers, PaaS, function as a service. And by the way, this is not, in fact, the full list. You will see much more, in fact, in the future related to this environment. So we have those. In the public cloud, we most likely are going to see containers, platform as a service, function as a service, and there is huge work that is being done over there by the different hyperscaler, Amazon, AWS, Microsoft, and all the others to provide extra services. Also, those services can be provided inside your data center with the like of Bitnami from VMware and other vendors. So you have different types of architecture. In the 5G network, we're gonna see mainly bare metal, virtual machines, containers, and on my mobile users, I'm gonna see most likely containers. So to summarize it a little bit before we open it up to questions, today we have looked at how the topology is expanding through 5G, proliferation of edge, and also the data collocation concept. We have seen that servers are changing from being simple vehicle to deliver x86 and cores to a more advanced platform that is hosting multiple accelerators. We have seen how the network is changing as well with software-defined networking, software-defined WAN, and the extensibility into the 5G network. We have seen how I can have different types of storage, how they can survive together, and where I need to put my data. And at the end, we have seen that from an application perspective, there is no single answer for where I put my application. It can be on bare metal, it can be on a virtual machine, it can be on a container, depending on the applications. And those are gonna survive and those are gonna stay. So this is the first part of the session. We'll have another session next week where we're gonna continue talking about the trends related to AI, ML, security, and multi-cloud environments. For now, I will open it up if you have any questions, so we can take them and answer you. And I would like to thank you for your time. So we have one question over here. Sorry, I had a problem with the YouTube chat. So we have a question about the storage. Either it should be depending on what capacity or technology or both. Well, it depends. It depends on both environments. So as we said, in terms of storage, you will be first looking at the application. Either it's traditional, either it's sort of new sort of application that is going to be linked to your hyper-converged infrastructure, or it is a sort of cloud-native AI machine learning types of application. So the application is one important factor. Also, from capacity perspective, this plays a huge role in determining which type of platform I'm going to put. So we plenty of vendors, they have different series. So we talk about the entry level, the mid-range, the high end. So each one of them has series that scale to a certain capacity. So from your perspective over here, we can see that both it depends on the questions that depending on the application and depending on the capacity, we will see the type of platforms. There is another question as well about the main areas of digital transformation. Well, there is a huge let's say subfields of when we talk about digital transformation. You have some companies define it as workforce, IT, security, and application transformations. You have also other fields related to, for example, if you come that are specific to a certain industry. In financial services, it's different than healthcare. So depending on the sector in which you are working, we can see different types of transformation. How can I improve my storage capacity? It depends. Well, usually, in fact, people they do assessments on this environment, and they will be capable to tell you more about this. That's how we can see it. These are the questions that I have for now. If there is anything else, please shout out. So I have addressed a few questions. So the same applies for the application as well. So if you have, as we were talking, depending on the type of the application, you will be capable to address on which technology you're gonna run it. Either it's container, either it's a virtual machine, platform as a service, or function as a service. And that's why when I talk also from a data center perspective, I talk about compute, network, and storage being assessed at the same time. So also over here, if I can reference a book that is, which is in fact two books over here, the Phoenix Project and the Unicorn Project, that talk about how we're gonna minimize or demolish the different walls that we have between our environments, either it's storage, network, and compute, and look at them from a single perspective, so we can accelerate and enhance the performance of our environment. So that's it from my side. I think we have answered the questions. If you have any other questions, please reach out to the Dell TRA Academy or to myself, and we will be more than happy to address them. I would like to thank you for your time today, and I hope that this session was beneficial for everyone. Thank you.